All right, section 1.5, we are learning to verify trigonometric identities. So far we've learned these identities. So we've learned the Pythagorean identity. We've learned what we call the quotient identities, where the tangent and cotangent can be written in terms of sine and cosine. And we've learned the reciprocal identities, which is basically the definition of secant and cosecant and cotangent being the reciprocal of these other trig functions, right? So right now we're going to focus on this Pythagorean identity because there are other versions of this that we can use as we're proving identities. So we need to know what all those possibilities are. Okay, so the first one comes from taking our Pythagorean identity and we're going to divide everything by cosine squared. So this is just kind of like, sometimes, I don't know if I've done this in this class, but called this the golden rule of algebra. Do what you do to one thing, you have to do to everything. You have to treat them all fairly, treat them all the same, right? So it's legal for me to go ahead and take my identity and divide everything by something, but it has to be absolutely everything that's affected by that. All right, going back to our list of identities, what is sine over cosine? We just talked about that. Now, of course, these are both squared, so I'm just kind of rewriting this as squared. Yeah, you don't have to do it that way, but this takes us back to an identity on the upper part of the page. Do you recognize which one it is? Yeah, so what is this equal to? What's another thing that we can say is sine over cosine? Tangent, right? So would this be true that the sine squared theta divided by cosine squared theta would be tangent squared theta? Does that make sense? Okay, what happens when your numerator and your denominator of your fraction are exactly the same? Perfect. Now this should be another identity, a reciprocal identity that you might recognize. 1 over cosine is the same thing as, it's the same thing as secant, isn't it? Cosine goes with secant, sine goes with cosecant. So cosine goes with secant, so this would be secant squared. I don't know if I needed to write that all out twice. I was just kind of, I probably wrote it more than I needed to, trying to make sense of it. I guess if I wanted to follow my pattern of what I'm doing here, I could have rewritten this part as 1 over cosine theta. So it's that thing squared, right? Because 1 squared is 1. So it would make sense to take this whole thing and write it as this thing squared, because that is what is secant, and then the squared makes it squared. Look, we have a new identity. Our new identity is tangent squared theta plus 1 is equal to secant squared theta. So this formula right here, right? Okay, guess what we're going to do to prove a different form of this identity? Any guesses? Yeah, let's divide by sine instead and see what happens. Okay, without doing this middle step this time, sine squared divided by sine squared equals 1. Good. And then back to our quotient identities. What is cosine divided by sine? Cotangent. Now, of course, cotangent is cosine divided by sine. So if this is cosine over sine squared, this would be cotangent squared, right? And then 1 over sine is cosecant. So that could be rewritten as 1 over sine, the whole thing squared. So that would be the equivalent of cosecant squared. Theoretically, you should memorize all 3 of these identities. Here's our basic Pythagorean identity. Here's the tangent Pythagorean identity. I mean, I don't have a specific name for it, but the one that has tangent and secant in it. And then here's our third version of our Pythagorean identity with cotangent and cosecant. In a perfect world, you would have these memorized. But if your mind blanks out, as long as you know this one and you understand the process we went through to find these, you could figure these out, right? Now, I don't know if you've noticed what's happening on these others. All it is taking this identity. When you have an established identity, you can move things around. So it's taking this established identity and moving stuff around. This one is just subtracting the sine squared from both sides. This one is subtracting the cosine squared from both sides. This one is subtracting the 1 from both sides, right? This one's subtracting the tangent squared from both sides. This one is subtracting the 1 from both sides. This one is subtracting the cotangent squared from both sides. So this gives us 9 different possible versions of one identity, which is going to be very helpful to know as we start verifying other identities. Okay, I'm going to go ahead and, well, let me just we'll just talk about what verifying an identity actually means. To verify or prove an identity, we typically start with the more complicated side of the equation and reduce it to the other side. In the next few examples, we will demonstrate several techniques to do just that, including perform algebraic operations, factor, rewrite each trigonometric function in terms of the trig functions that appear on the other side, multiply numerator and denominator by the same expression, apply trig identities, combine 2 or more of the previous techniques. Now, until you have an established identity, you never move things across the equal sign while you're verifying it. So I realized that we just barely took these problems and we moved stuff. That was okay because we knew they were true. But when your job is to actually verify that something is true, you cannot move things from one side to the other. You have to just work on the right side or work on the left side, or you can work on both sides and make them match. But you can never move things over. No golden rule of algebra on verifying identities. Okay?